All right. Now the next one I want to talk about is fine grain. With fine grain, okay, now this would be extremely fine, right? We went from coarse to medium, now we're at fine grain, so we're getting very, very small particles. Okay, this is mostly going to be silt and sand. If you want to think about the differences between silt and sand, what is the problem with it? Let me tell you this way. When we think about sandstorms, although some of the sand does get kicked up in the atmosphere, most of the sand particles are actually at near ground level, so maybe 100 feet of the ground or rolling around on the ground. It's the silt that gets thrown all the way up into the upper atmosphere. It can sit there for multiple days and travel over thousands of miles. So when we think about the Great Deserts of China, gentlemen, what is the issue? Knock it off. So when we think about the Great Deserts of China, a lot of that is mostly silt that comes off the steppes of Eurasia and travels across the entire continent of Asia and then drops the silt over China. So silt is very, very fine and can travel a very long distance because it has a very low density, so it's not very heavy at all. When you look at shale, that's the silt. So really it's more clay, but silt and clay together will make the shale. And remember, because it's so fine, when they lay on top of each other, you're not going to get a lot of pore spaces, right? We saw that on Friday. You put the shale underneath the water, you put the sandstone underneath the water. What happened with the shale? What would the water do? It just ran off, right? You couldn't even absorb into the rock. That's because there's no pore spaces to absorb into. So another common characteristic with fine grain clastics is that you have extremely thin layers. Remember, we call that bedding. So we have extremely thin layers, and we have very low porosity compared to coarse grain and medium grain. So we have almost no pore spaces available with your fine grain plastics. So with that in mind, ask yourself a very simple question. If we understand that shale has a very low porosity,
the water will not fit in through the little pores.
Okay, so it means the water can't pass through it. What does it tell you about oil? Would water or would oil be able to run through the shale? No. So what's kind of neat about that then is this actually creates an impermeable layer. Okay. What does it mean to permeate? These are big words. Permeate. No, not permanent. Permeate.
I thought maybe
What does it mean to permeate? Okay, it's permeate is the same as a synonym for penetrate. So it goes through. To go through. So if something is impermeable, what does that mean? You can't go through it. So a lot of times your shale will actually become an impermeable layer, and then it becomes the bottom of your water table. Water can't go down any further, so it just sits there on top of the shale, same thing with oil. So it's kind of a good thing. Now, have we ever heard of artesian well before?
Okay, so about like, and the impermeable layer is for groundwater and oil. I thought you said oil could fit through it.
Cannot fit through. Now this is kind of interesting here. We think about artesian wells. Let's say you have a shale layer down here acting as an impermeable layer, also known as an aquiclude. And we'll talk about that much later in next quarter.
So impermeable, it means to not not be able to go through.
Yep. So the shale acts like an aquafluid, preventing anything from being able to pass through it. And then between that, let's say you have a sandstone layer full of water, okay, super saturated, and then you get another shale layer on top of it. What's happening with all this weight? What's it going to do to the sandstone?
Compact it.
It's going to compact it. What's going to happen with the water, though?
So it's squeeze.
It's going to squeeze the water, but can you really squeeze the water out?
No, you can't.
No. But what's kind of neat about this is most of you guys you have well water. Think about that. You have a well, which means you have a pump that's sucking the water out of the sandstone. With an artesian well, you have it squeezed between these two impermeable layers, so it can't go up and it can't go down. So it's really highly pressurized water. It's like having a balloon that you have completely filled up as high as you can with any air, and you take a pin and you frick it. What happens? It explodes. And the reason why it explodes is you have this sudden rush of air going out and literally rips the balloon apart. No. So, if you, an artesian well, just all you have to do is dig down and break through that sandstone. There's so much pressure in here that pressure sends the water up your well, and you won't need a pump to draw the water out. It will automatically run on its own. So it's kind of cool. It's very rare to be able to find the right environment, let alone to buy into that correct environment to find or to basically create the artesian well. But it's really kind of a neat, simple concept. No, because most of what they did in old wells is they would literally dig the full channel and then it wouldn't fill all the way to the top. You have to let the bucket. This actually will bring it all the way to the surface for you. And then all you gotta do is tie in the pipe and bring it up to your house. Well, today you have a pump that sits a little bit below ground level and it literally sucks the water up. This does it completely without any energy having to be spent. It just put it down the pipe and the water will fill up the pipe. Kind of cool. All right, let's talk about chemical sedimentary rock. Guys, this is a big test question I'm going to ask you. How do evaporites form? Okay, this is a really big test question. Not evaporates, evaporites. Okay, the types of minerals. An example of this is this mint green aurora chalcite. Okay. This is an example of an evaporite. I'll pass this around for you guys to take a look at. It's really kind of cool. When you look at it, this looks like someone took a little bit of paint and just spray painted it. But it's actually really kind of a cool concept. In the ocean, you have all this tremendous amounts of water, right? And then because you have so much water, it can dissolve a lot of stuff, right? So when that water then goes into a restricted basin, think of it like a lagoon, okay? The water can no longer keep everything in a dissolved state. So what does it do? Okay, let's try and think about this, guys. Take a pan of ocean water and set it out on the beach for a day. Tell me what starts to happen.
Evaporates.
Okay, evaporates, then what?
The
Salt's left behind. So if the water's evaporating, salt gets left behind. So that's important because the same concept's going to happen here. The reason why the salt's getting left behind is because now the amount of water left in the pan is not enough to keep all that minerals in a dissolved state. And there's only so much the water can dissolve until it reaches pure saturation. So when you're in a restricted basin, you're in a limited amount of water. So therefore, you can't have everything still dissolved. So those dissolved minerals start to fall out of suspension, and they start to grow on the bottom of the basin. Okay, so now we start getting this thin layer, this very thin layer of minerals that build up on the bottom of the basin as the water is evaporating. And then as that keeps happening, you get larger and larger crystals that start to form. And this is based on how we get limestone, because you get calcium carbonate that basically goes out of dissolved state and starts to form in the basin. Right? That's why we have large salt deposits underneath the city of Detroit. They go into Lake Erie. You have all along the whole Lake Erie basin with these huge salt deposits. And that's because as that water comes in and it evaporates, it leaves behind the minerals. So this is basically how we get the evaporites. Okay. Common evaporites that we can get: calcite, gypsum, and halite. And these are your most common. And each one of these creates different types of sedimentary rocks. Your gypsum, you guys ever heard of White Sands, New Mexico? Okay. White Sands, New Mexico is a national park. And instead of having the nice, wonderful brown sand we're so used to, it's actually white. And it's white because of the amount of gypsum that has been eroded, and it actually becomes gypsum sand. That's basically what you're saying. Now, you can have some pretty other cool pictures. Right here's another example. And this is from down in Mexico. And again, you can imagine this whole cavern being filled with water, but then these minerals, as they start to grow, they give the surface for new minerals to grow on top of that. So you actually get the crystals that continuously grow within the water. Yes, Brian?
This white stuff on top of the rock.
That's the mineral.
So those crystals are done
Green.
Yeah, as soon as you remove the water, Brandon, the crystals can no longer grow.
Let water flow through
And then as long as that water flows back through them, the crystals will begin to grow again. Alright, the last thing I want to talk about are organic. Again, organic means that we come from living organisms. Okay? Limestone is a perfect example of that, and that's from seashells. So seashells, okay, also known as calcium carbonate. Okay, CaCO3. CaCO3, calcium carbonate, is limestone. It's made from dead things in the ocean. So when we have a large deposit of limestone between us and Chicago, right? If you take 80 and you go across, you drive across this immense gap in the Earth's surface that is basically where they quarry the limestone. That tells us, if you want to think about it, right here is Michigan, right? And over here we have Wisconsin. And Wisconsin has this big jagged edge that comes off like that, right? This whole region, all the way down through here, up across Michigan, all the way up to Niagara Falls, and back down through Chicago. Ancient, very, very ancient coral reef. And in fact, that's where we get the split between the UP and the Lower Peninsula. We have the Mackinac. Another common type of organic is coal. And that's all I have for you guys. So, all right. So here's what I want you guys to do. We're going to stop.